Hello, everybody. Welcome to my lightning session for CDK Day event. In this session, we will work together to deploy a generative AI model using AWS CDK. My name is Neelam Koshia, and I'm a Principal Solutions Architect at AWS. My background is software engineering, and I organically moved to architecture role with my area of depth being machine learning. So this session is primarily marrying machine learning with engineering or DevOps component, which is CDK. Now, the session is a short 20 minutes duration, and what best way to deliver this than working together to deploy it? My slides are limited to highlighting some details and concepts that will help lay the foundation or baseline for our audience today. So let's jump right in. Let us begin by asking, where does Gen AI fit in? Yes, Gen AI is a subset of deep learning, which is a subset of machine learning, which all rolls up to artificial intelligence or AI. The seed of machine learning paradigm shift have existed for decades, but with readily available, virtually infinite compute capacity, massive amount of data, and the rapid development of machine learning technologies, customers across industries are rapidly adopting and using machine learning technologies to transform their business. Just recently, Gen AI applications have captured everyone's attention and imagination. We are truly at an exciting inflection point in the widespread adoption of machine learning, and we believe every customer experience application will be reinvented with generative AI. Let's take a step back and see, how did we end up here? What happened suddenly? It didn't really happen overnight. Natural language processing has been around for many years, but it experienced kind of a renaissance with word-to-vec. Some also call it shallow neural network. Then in June 2017, there was a paper which was published, and it introduced transformer architecture and concept of attention. The paper is pretty popular even now, and the name of the paper is Attention is All You Need. Highly recommend reading that. Now, the biggest architecture after that, like GPT and BERT, are still around. And yes, the T stands for transformer, and both are leveraging transformer and attention. Now, what happened over the years? There was improvement in parameters, and with development improvement in compute capacity and data, the model eventually jumped from a million with an M to a billion with a B, like GPT-3 having 175 billion parameters. Now, this is when we started talking about LLM, also called as a large language model, and community came together to build more and more open source models. Now, the ones in red here are open source LLM models. This is the phase we are in right now, and we see every week there is new models, and we are seeing increasing emergence of AI/ML startup focusing on large language models. Now, let us ask the most important question, right? What is actually generative AI? So generative AI is a type of AI that creates new contents and ideas, including conversations, stories, images, videos, and music. Like all artificial intelligence, generative AI is also powered by machine learning models. These are very large models that are pre-trained on vast corpuses of data, commonly referred as foundation models. Recent advancement in machine learning has led to the rise of models that contains billions of parameters or variables or features, as we call them. Now, why are foundation models so popular? So if you look at a traditional machine learning model, in order to achieve a specific task, say in this example, text generation, customers need to gather label data, train a model, and then deploy the model. Now, that's a paradigm shift versus how foundation model work. So for a foundation model, instead of gathering label data for each model, for each task, and training multiple models, customer can use the same foundation model and adopt it to various tasks. For example, you have various foundation model being trained on Wikipedias of the world. And that particular model, also known as a foundation model, can then be used to adopt to different tasks like text generation, summarization, Q&A, chatbot, etc. Now, the beauty of foundation model is that foundation models can be customized to perform domain-specific functions that are differentiating to their business, using only a small fraction of data and compute required to train a model from scratch. So now that we have talked about the Gen AI part of the topic, let's focus on the other part, which is CDK. So AWS CDK is an open source software development framework to model and provision your cloud application resources using familiar programming language like Python, Java, etc. Now with CDK, you will be much more faster than with any previous tool to, have that fast cycles from conception to deployment and then maintaining it, because you would work with familiar language like we are going to do in Python today, and concept, and the same familiarity with classes and methods without doing context switching. With CDK, there is actually a paradigm shift on how we provision multiple environments. Previously, with CloudFormation, we had one template with parameters for multiple environments like dev and test. Whereas with CDK, there is a shift wherein you can have multiple templates that would generate code for and stacks for each environment. So now that we have a baseline idea of the two pieces, which is Gen AI and CDK, let's now talk more about what project we are going to deploy together today. Here we are in Hugging Face. So Hugging Face is a repository where you can look for models, data set, etc. And we are going to access two of the models which is available in Hugging Face for our example. So the first model is by Stability AI. It's called as Stable Diffusion 2.1 base. Now, what this model actually does is it takes a text as an input and it creates, based on the text prompt, it creates an image. So it will take text as an input and the output will be image. And then if you look at this particular page, you can, get more details about how the model was created, what is the licensing, and who developed the models, etc. You can also additionally take a look at how many times this was being downloaded. So it's a pretty popular model, specifically in the image space, and it has around 600K downloads. So that's first model, which will help us to do image generation. And the second model that we are going to use today is Google's Flanty 5 XL. And this particular model is going to help us generate text. So here is a good picture about the multitask instruction fine-tuning that you can do. However, I'll just scroll down and we can, look at more details about this particular model, how it was trained. So it is under the Apache 2.0 license, and then there are more resources and you can read more about it. And you can also check on how you can use the PyTorch model and how you can run this model on CPU and on a GPU. And then what are the uses for this particular model? You can read more details about it. But basically, it's going to take a text as an input and generate do things like natural language understanding, like summarizing the details, in our example, but basically doing text generation. Now, the project that we are going to use is the project called as Generative AI SageMaker CDK demo, which is in the AWS sample. And that's how we are going to, there are instructions here, but we will work together to today and demo it to show you how we can deploy this project. And then the project is leveraging something called as Streamlit for its front end. And what Streamlit is actually doing is it's a simple open source a Python library, which makes it easy to create custom applications for machine learning and data science. And it's honestly few steps, very quick to get started. You can get started with Streamlit on your favorite IDE. And then once you have a decent code, you can push it over to AWS by using few lines of code. And Streamlit works great. Like the way you can deploy the Streamlit application is using the Copilot, which will simplify the deployment to Amazon ECS. So another thing that we'll be using today is the SageMaker JumpStart. So SageMaker is a fully managed service. So if you go to SageMaker in your AWS console, you can read more details about it. But basically, it's a fully managed service, which helps you through the end-to-end life cycle of machine learning, from building, training, tuning, at scale. And one of the components that we're going to use today from a SageMaker is the JumpStart. And in JumpStart, you can see it opens up in something called as SageMaker Studio. So SageMaker Studio is essentially an IDE where you would be, ideating, deploying, having ML ops, etc., everything in one place. And over here in the SageMaker Studio, you can also see the JumpStart. So what JumpStart is, it's actually a repository where you can find the pre-trained models, we can find solutions. There are other resources like notebooks. If you want to find something specific to frameworks like TensorFlow, PyTorch, you can go and find that. And you also have a search bar here where you can look at the different models which are available. And you can also deploy those models by using a one-click option. So here are some of the text generation models. So some of the more advanced like Llama, Jurassic Family, Cohere command is here. And then we have image generation. And then if you're looking for end-to-end solutions, that is available here as well. So now that we have some of the key pieces highlighted, let's take a look at the architecture diagram. Now that we have provided some context about AI, Gen AI, and CDK, and some of the pieces that we're going to stitch together to put this process, we will now deep dive into our architecture flow. There are two pieces to the application. There is a web application front end and the back end. So the web application front end is built on Streamlit, like I mentioned before, which is an open source Python library that helps you to create web apps in a very simplistic manner, specifically great for ML and data scientists. And we will host this using web application, which is running on ECS. So here we are, and this is the AWS Cloud, and we will be deploying the web application, which has the application load balancer, and then hosted in containers, specifically ECS, which is pulling out the image from ECR. Now let's talk a little bit more about the backend. So the generative AI model endpoints are launched from JumpStart images in ECR. So we have SageMaker JumpStart, and then we also have ECR, which is actually storing the container images for those models. And then S3 has all the artifacts like the model data, etc., which will be referred. The models are hosted with SageMaker endpoints. SageMaker endpoints, which will be actually referring to the ECR for the image and S3 to host the models. And then the endpoint, which is hosted in SageMaker, will be fronted by or exposed as an API by leveraging the famous serverless combination of an API gateway and Lambda. And we have two different APIs. One is for the text generation, other one is for the image generation. And like I mentioned, both of the endpoints will be referring to the image and the artifacts in S3. And our front end will be calling these two APIs as which will serve as a backend. And then we will be having our AWS CDK, which will help us to orchestrate and deploy this particular project in the form of a CloudFormation template and get it ready for us to test it out. So now let's have a practical implementation and let's do it together. There are some prereqs that are required before. So let's go ahead and make sure that we have those prereq installed. So first one is having the AWS CDK. So I'm going to do npm install the CDK library. The next step, we're going to check the CDK version. So let's take a look and check the CDK version. And then let's ensure that we have Docker installed and okay. So, and the version of the Docker. I'm going to do the git clone of the project that we share is the project in the IDE. So there are different folders in this project, and I just wanted to highlight, what folder has what. So basically the stack folder over here has the different stack that are created for the CDK application. So if you look at this, we have the VPC network stack, which will actually create the basic networking construct, right? Create the VPC, security group, subnet, etc. And then we have the web stack, which will actually be deploying the Streamlit application, the web application with the ELB, the containers, everything into AWS. Basically helping us orchestrate and deploy the web stack, which is the front-end web application where we will be doing our testing. And then we have the two other stack, one stack, which is for the text to image, which will be deploying the end-to-end flow for the text to image, including the SageMaker endpoints and the other artifact aligned to that and the Lambda functions, which will help us to create those serverless API to call those models. Similarly, for the text generation as well, which is text to natural language understanding text. Now, if you look at the code, you can see the code for the two Lambda functions. So here's the code, which is for the text to image. Basically, what this Lambda function is doing is it's invoking the SageMaker endpoint by leveraging the invoke endpoint API. Similarly, for the natural language processing for the understanding for the text generation as well. You can also see the cdk.json file, which actually tells the AWS CDK toolkit how to run this particular application. So it has the details about that. And then we also have the web app folder in here, which is actually our Streamlit application, which has our homepage, wherein, this will be the page that will be displayed when we are going to have the web application front end and all the other pages under it. So we have one page for text generation and one page for image generation. Let's take it further and deploy this application in AWS. So first thing we are going to do is we are going to create a standard Python project, and we will create a Python virtual environment. After that, we will activate the environment. And then we want to make sure our libraries are up to date, specifically the pip. So let's install that. And then we will also install the requirement. While that is getting downloaded, just wanted to uninstall, just wanted to show you the different requirements for this. So basically we need the Boto3, the matplotlib, matplotlib, request, Jinja, and Streamlit for our application, and that's what it's doing. Before you deploy any CDK application, you will need to bootstrap a space in your account and the region that you're going to deploy in. And typically, when you do AWS CDK, AWS configure, you are actually using the AWS CLI to connect to the AWS environment. So before doing that, I highly recommend doing AWS configure. Make sure that you have a profile set and then use this command to bootstrap. Okay, so in a couple of seconds, you'll see a CloudFormation template in the AWS account where you have set up on your AWS CLI. And you can check the different events that has happened, but most importantly, you can check the resources that were created as a result of this particular CDK bootstrap command, right? So it created the staging bucket, it created the roles, IAM roles, policies. So now let us begin by doing the CDK deployment for the different stacks. Remember, we mentioned about the 4 stacks, right? So the first stack is the foundational stack, which will create the VPC network constructs for our project. So let's deploy that. So once the networking components are deployed successfully, we will then go ahead and deploy our web front end by using CDK deploy the web stack. And then similarly, we will deploy our text generation stack as well. So our deployment of that particular stack is complete. So you can see in your CloudFormation that it is complete. Now that we have deployed one piece of it, let's go to our web stack, get our URL, and try it out ourselves. So here's the web stack URL, and you can find it out in the output of that particular stack that you have deployed. So this is our URL. Isn't it looking really cool? It's a Streamlit application, and these are the multiple pages that we have created. So let's try the one that we have already deployed, which is the image generation. So this is a simple prompt, and I'm going to generate an image. You can also see details like the API gateway URL that it's calling and the endpoint. So let's generate the image. So there you go. That's our dog in a superhero outfit. Isn't it really cute? So similarly, you can deploy the next stack, which is the text generation, and try out that as well. So let's go ahead and do that. And let's wait for it to complete the deployment, and then we can try the text generation. Let's go ahead and test text generation. So in this particular example, we are using the same Flank T5 Excel, and this is a interaction between a customer and a customer service center, contact center agent. And what we can do is we can have the context provided over here, and we can ask a query, write a summary of it, and then the model will go ahead and summarize what really happened. So that's one use case. And then another use case is what are the steps suggested to the customer? So you can ask other natural language process query and get more details out of it. So there it is. We have completed the 2 use cases using CDK. I hope you enjoyed it, and thanks very much for joining. Thank you and bye.